Hello, my name is Joshua Weaver and this is my presentation on predicting patterns of prejudice for ECM3420 learning from data. The research question I've attempted to answer was to see if machine learning can be used to predict future hate crime trends for diverse offence categories in New York City based on historical data. In 2022, New York City witnessed 670 reported instances of hate crimes, a concerning statistic that demands attention. This project's goal is to enhance the safety and well-being of New York City citizens with the use of machine learning and its data-driven approach to identify patterns. The motivation stems from the need to proactively tackle the rising challenge of hate crimes, as they not only harm individuals but also impact the community. Through this research, the goal is to provide valuable insights for law enforcement, policymakers, and community leaders, empowering them to implement effective preventative measures. The broader goal is to foster a secure and inclusive environment, minimizing the impact of hate crimes, and contributing to the creation of safer communities. Machine learning is well suited for predicting future hate crime trends in New York City due to its ability to understand complex patterns and handle large data sets. Its data-driven approach and feature importance analysis contribute to accurate predictions, making it a valuable tool. The dataset used for this project was retrieved from one of the official websites of the United States government, data.gov, and was published by the City of New York. It catalogues confirmed hate crime incidents within New York City from 2019 to 2023 and was what provided me with the 670 reports of hate crime statistics seen earlier. It provides an array of valuable insights into the nature, characteristics, and circumstances surrounding each incident. The key attributes used were complaint year number and month number, denoting the year and month of the complaint. Also, the offence category classification was used as it states the specific category to which the offence relates. This information formed the foundation for the analysis of hate crime patterns. The other attributes include, but are not limited to, the full complaint ID, serving as an identifier for each complaint, as well as the complaint precinct code, patrol borough name, and county, offering geographic context to each reported incident. Ridge regression was employed for the analysis. It is a supervised learning technique used for predicting a continuous outcome based on one or more predictor variables. I believe it is a good fitting choice for this project as it extends the capabilities of linear regression by incorporating regularization. Before the data analysis, there was a pre-processing step aimed to optimize input data for the ridge regression. It involves the correction of data, ensuring an accurate representation of the underlying structure. However, it poses a risk of removing relevant information. The process involved data cleaning. Missing values that were expected but were absent were filtered out in the key columns of complaint year number, month number, and offence category. In my ridge regression, a penalty lambda, a hyperparameter, is applied proportionally to the squared coefficient values. A hyperparameter is an adjustable configuration setting that influences a model's training. This penalty imposes bias on the model and reduces variance. The best value for lambda was selected via cross-validation. I produced the different instances of the data analysis graph with varying values of lambda, including 1, 5, 10, and 100. I found that the coefficient of determination, better known as R squared, was at a sufficient level at lambda being 5 for an appropriate bias-variance trade-off. Cross-validation was used to optimize data use. It ensures a reliable error rate. The process involves shuffling the dataset, splitting it into n groups, iteratively using each group as a test set while training on the remaining groups, evaluating the model's performance, and summarizing the overall model performance based on the evaluation scores. The data analysis revealed informative insights into the hate crime trends in New York City. It produced a graphical representation of monthly incidents represented by points on a timeline, as seen here. The distinct colors denote various offense categories, the solid lines depict the historical regression trend, dashed lines extend into the future, illustrating predicted trends. Finally, each line concludes with a numerical gradient coefficient. The results showed a concerning increase in the overall incidence of hate crimes over time. Within specific offence categories, a prevalence of incidents related to religious and religious practices is evident. Projections indicate an anticipated growth in hate crimes based on sexual orientation, surpassing 10 incidents monthly by 2025. Additionally, an expected rise in incidents related to race, colour, ethnicity, national origin, and ancestry were predicted. These results provide a valuable foundation for proactive measures aimed at addressing and mitigating the escalating challenge of hate crimes in the city. There are two main areas of limitations in this project. They are data and method limitations. Firstly, the dataset sourced from the NYPD hate crime records may be subject to reporting biases and underrepresentation, as not all hate crimes might be officially reported or recorded. This means the predictions given for the trajectory of these crimes in the future may not be representative of the actual trend. Additionally, the dataset's temporal scope, spanning from 2019 to 2023, might not capture long-term trends adequately. Also, with missing variables, such as socio-economic factors, the model is limited in its explanatory power. For the method limitations, the methodology's reliance on ridge regression, while providing valuable insights, has its own set of constraints. The exclusive use of ridge regression might oversimplify the complex dynamics underlying hate crime patterns, potentially overlooking non-linear relationships. Also, the removal of data points meant that the new dataset would be less representative of the original. However, reports with missing data are unable to plot, so the step was necessary. Moreover, the dataset may contain outliers. Outliers can influence ridge regression by exerting some impact on the model, although the regularization term in ridge regression helps mitigate their effects to a certain extent. Finally, the model may suffer from overfitting. The regularization term also addresses the bias-variance trade-off by preventing the model from fitting the training data too closely, which helps control overfitting. In summary, this study emphasizes the pressing need to tackle the rising issue of hate crimes in New York City. While the ridge regression model provides valuable predictive insights, its interpretation requires caution due to inherent limitations in the dataset and methodology. To effectively combat hate crimes, a comprehensive, multifaceted approach is crucial, extending beyond reported incidents to encompass socio-economic factors. Utilizing more advanced modeling techniques is vital for capturing the nuanced dynamics of hate crimes. The ultimate objective is to foster a city that celebrates diversity, necessitating collaborative efforts to address root causes, implement proactive measures, and continually enhance analytical tools for a safer and more inclusive future.